Hello and welcome back to the second part of Chapter 2. So we're going to pick it up with the benefits of good design. Key thing here is that if you take the time and do a good logical design, it's going to save you a lot of time in the long run. It saves you time by making it easy to modify and maintain that database structure. It saves you time by keeping the amount of duplicates that might have to be updated to a minimum, and it makes it easy to modify that. It also makes it easy to retrieve that information. I guess, we really haven't seen any databases yet, and so when you're thinking about retrieving information, think about if you have to connect up 4 or 5 different tables in order to get information from the first table and information from the last table. Chances are that's probably some type of poor design. And so having all those tables in memory and everything having to link up based on a certain primary key and all the other keys in the other tables, it's going to take a long time to retrieve that data for that report. And so that's what we mean by information is easy to retrieve if that database structure is designed properly. And then if you have a good structure, it's going to be easy for you to then develop on top of that the applications that you're going to need. So those end user applications. So typically, once the database is built, then somebody's going to start designing some forms so people can input the data, so they wouldn't just type it right into the database. There'd be a form on the screen that they're filling information out, similar to what you would see when you go to a doctor's office. They'd also have another screen that would have different queries or different reports that this application could generate for the end user. So all the user would have to do is just press a button and it would generate that report for them. Good database structure design is going to allow you to build those applications easier. Otherwise, if it's poorly designed structure, then somebody's going to have to write a lot of code in order to gather all the data and place it where it needs to be going. So that's what we mean by benefits of good design. So what is this method of database design we've been talking about? You can think of it as some sort of traditional database design methodology. So typically it's your requirements analysis that you're going to be doing. Once you have all your analysis, you've talked to people, you've seen how things work, you've seen the processes in place, then you're going to try and model that. And then once you start building your tables to collect the information, you want to normalize those tables. Now, in this book, you're not database administrators. We will not deal with normalization in its purest, most technical form. You won't have to be thinking about, is this table in third normal form or some other normal form that makes it useful. All right, so specifically, when we talk about requirements analysis, anytime you're doing an application design, you're going to do a requirements analysis. So that looks at the business being modeled. You might have interviews with end users, managers, anybody that's involved with that system. You're going to look at the current system, or how are they currently doing it. It could be a manual system. And then you're going to ask them what is it that they want out of this in the future, so that you can kind of build that into your design if they want to add certain things or have the ability to do certain things. Then you want to look at what are the information requirements for the business. What data do they need to collect in order to generate those outputs? Then you have the data modeling phase. This is where you're doing some diagrams, you're drawing, you're sketching that database structure. Typically, this is going to be called entity relationship diagramming. That's what the ER stands for. So that identifies the relationships and the relationship types. You're also going to identify the candidate fields for primary keys and foreign keys. Keep in mind, these primary keys is nothing more than a field or a group of fields that when you combine the data or just look at that unique data, it uniquely identifies the row or the record in the table. So for us, what you've been used to is either your social security number or your student ID. Here we have examples of an entity relationship diagram. The rectangle represents a table. That is, this table, or in database design terms, is a person, place, or thing, or an entity. For us, they're going to refer to it as tables. It has fields in here. What information about agents do we want to collect? We don't show that on the ER diagram unless it's further in the details. So it might be first name, last name, address, salary, things like that that are unique to that agent. The diamonds represent the relationship. So this is one way to do that ER diagramming. So this is how this person did it. A relationship can either be one-to-one, written as 1:1, or 1 to n, which represents one to many, which is the most common type of relationship you have. Or if you see something like M:n, that is a many-to-many relationship at the logical design level. The vertical line represents that it's mandatory. A circle represents it's optional. Okay. So where's that circle? Where's that line? These two things, this vertical line and circle, in database terms is called cardinality. The cardinality of a relationship represents the minimum and maximum values that have to exist in our logical design. So in this case, the way we'd read this, an agent can have 0 or many clients. So the circle here is optional. So that's 0. That's the minimum value. Now we can read it backwards. A client has to have one agent. Now if there's two single lines here, two vertical lines, that's typically read as one and only one. In this case, I think they mean the same thing since this book is a little older than most relational database design books. Now, the way this reads is the client can have one agent, or it needs to have one agent. So one agent can have many clients, a client can have one agent. See how I'm reading that backwards and forwards? Now, in terms of implementation, I'm just bringing it to your attention now so that you'll get used to this. When I actually create this database, what this design is telling me is that I can enter agent information, and that's fine. It doesn't need to have any clients or anything with that particular agent. But if I go and start to enter client information, maybe it's first name, last name, address, who knows. But when I start to enter that information, there's also going to be a field in this client table that relates back to this agent field or agent table. So what this is telling me is I can't enter a client unless an agent exists for this client already. I've got to, in order to save that record, I'm going to have a foreign key field value to put in there for that agent. So an agent might have an agent ID, and that's linked to another field called agent ID over here in the clients. If I don't enter that field, I can't enter the clients. That's equivalent to something that you would be familiar with. That is, you couldn't enter your student ID or your information in a class you want to enroll in unless you existed as a student already. And I use that example in the other first chapter. Right? So that makes it mandatory when it's read like that. Okay? The different relationships, again, this is how they are shown. One-to-one, one-to-many, and many-to-many. It's all at the logical design. So in order to think about good database design, look at this quote we have here. A table should have a field that uniquely identifies each record or each of its records. A field. So that field might be called student ID or social security number. And each field in the table should describe the subject that the table represents. So again, that table represents a person, place, or thing you want to collect information about. And so every field in that particular table should only be an attribute for that person, place, or thing you're collecting information about. Hopefully that makes sense. And we'll see more examples later. And so that ends what I wanted to talk about for Chapter 2.